Leave at 2:05.
Math is a farce.
Alright, so let's continue with this and the connections between the two graphs. If the derivative is greater than 0, that means that the derivative is what? Positive, right?
Yeah.
So what do we know about the original function if the derivative is positive? Very good. So the original graph is increasing. What do we know about the original function, bless you, if the derivative is less than 0? What does that mean?
Negative.
Negative, so therefore the original function is decreasing. Okay. What if the derivative changes from positive to negative?
Relative minimum.
The function changes from what? If the derivative changes from positive to negative, the function changes from increasing to decreasing, meaning that it has a relative maximum. Yes? Okay. What happens if the derivative changes from negative to positive?
It changes from decreasing to increasing.
The graph changes from decreasing to increasing, which means what? That it has a relative min. Good? Alright, so what we're going to look at down here is we're going to start working on this. And on the left side, we have the original graph of f of x. On the right side, what I want to draw is the graph of f prime. Okay, so this is going to be the graph of what? F prime of x, which we know is the what? The derivative. And this is where it's going to get interesting, okay? Because I want you to think of this graph over here as, so think of it as a list of, what does the derivative tell us? Slopes. Okay, so the derivative, I'm going to have to look at it as being a list of slopes. So it's just going to be a bunch of points put everywhere, and those points are going to represent a list of slopes. So if I ask you, what is the slope at 5, you're going to go to 5 on the x, and wherever that point is, whatever y value it's at, that's going to be the slope of the tangent line at 5 for the original graph. Do you understand? So for example, if I put a point here at 3, 0, what could you tell me about the slope of the tangent line at 3? What do you tell me about the slope of the tangent line?
It's
What's
positive.
the value?
Positive.
0. Why is it 0? Because at 3, where am I at? 0. What if at 4, I was at 5? What's the slope of the tangent line at 4? 5. I'm listing what? Slope values at different x values. You understand? Alright, so I'm going to get you started here, and for homework, you're going to finish listing them, okay? That's all you're going to do for homework, because we're not going to get farther than this. So we're going to use this graph, and we're going to find slopes at only certain points, and you're going to list them over here. Ready? So let's do this first point, which is at -7. So when I'm at -7, what's the slope of that tangent line at -7? Let's use an approximation. So I'm going to use this point right here. And I'm going to approximate using those two. So what do we get for that slope? 4, right? 4 up and 1 to the side. So that means over here, I'm going to list it. So I'm going to go to -7 because that's the x I was at. And what did I get when I got that derivative? 1, 2, 3, 4. That slope was 4. You understand? Okay. How about the next one? Now I'm at -6. What's the slope of that one going to be? 2? 1, 2 over 1. So at -6, what am I going to list it as? 2. Understand? How about at negative 4? 0. So where is that? On the x-axis. I'm listing it. I go to that x and I put it where it needs to be. You understand? Okay, let's keep going as far as we can go before the bell rings. What's this one going to be? Negative 1?
Yes.
Want to do negative 1? 1 down, 1 to the side, is that okay? Okay, so that means that at what x? Negative 2, we're at negative 1. It's actually a little bit lower than negative 1, we're going to find out, but it's okay. We're just estimating, right? Okay, we're listing the slope at that x value mark. What's the next one going to be? Negative 2? Yeah, that's a good one. We try to get here, right? So that's 2 down and 1 to the side. So that means at negative 1, we're going to list it as what? Negative 2. What is it at positive 1? 0. So at positive 1, it will be 0. Yes? And how about here? 3, let's see, 1, 2, 3 over 1. Nah, there's gotta be a better one. 4? Yeah, 4 looks better. So that means that at 1, 2, 3, we should be at what? 4. Okay, good. How about at, with that, 1, 3, 4, 5? At 5, what are we at?
0.
At 0, and let's finish it before the bell rings. What's the slope of this guy gonna be? See, 1, 2, 3 over 1? Yeah? Will that work right there? Negative 3? Or negative 4? Negative 4? That's positive 7. You want to do negative 4?
Yes.
Okay, we'll do negative 4. Just estimation. What if I found more tangent lines and found the slopes of all those tangent lines? Would I have more points listed?
Yeah.
And what kind of a curve do you think it would draw? Or it would form? Because I'd be putting a whole bunch of points in between here, right? So it would make like a little curve like this, right? And then it would go up. And then it would come back down. And what does that look like? Like a cubic function, right? So this is cubic, so that means this one had to be what? Quartic. Why did it have to be quartic? Because the derivative should be 1 what? 1 less. So if I have a quadratic function, what should my derivative look like? A line, right? Because it's 1 less. What if I had a line? What should my derivative look like? A constant function, right? Okay? Do you understand? Yes? Can you visualize it as being a list of slopes? Where are my slopes 0? No, tell me, where are my slopes 0? At what x's? At negative 4, 1, and 5. So when my slope is 0, that means my original graph should have a what or what? A relative min or max. So do I have that? Do I have a max at this value? And a min at this value? And a max at this value? Okay? So on Monday we'll continue talking about this, right? You won't have any homework regarding this packet yet, right? So those of you watching the video at home, there is no homework over the weekend. We'll finish the notes on Monday, okay? Good? Alright. Have a good weekend. We'll see you on Monday. Catch up with your work if you haven't finished it.